today's presentation is about natural language processing. And this is the fourth and the final presentation of a series of presentations we have about application of various AI methods in orthopedics. Not that these methods are only used in orthopedics, but we try to focus these workshops to musculoskeletal diseases. So this workshop series is supported by T32 training grant in musculoskeletal diseases from the NIH, where Dr. Jan Westendorf is the PI. And it's also supported by a couple of other infrastructure grants at Mayo related to clinical research in orthopedics. And the original funding comes from the Office of Data Science Strategy at the NIH. And today's presentation is by a group of scientists from the Department of AI and I at Mayo. And this group of individuals, these three individuals, have been working on several orthopedic research studies over the last couple of years. So in addition to their methodology expertise, they do have experience in NLP applications in orthopedics and musculoskeletal diseases. Dr. Seung-Hwan Som will go first. He's an associate professor of biomedical informatics with expertise in NLP, machine learning, and specifically applied to EHR text analytics. He was instrumental in developing several NLP tools that we currently use enterprise-wide at Mayo Clinic. And he's a co-investigator on a number of NIH grants focused on musculoskeletal diseases as well. Elham Sagheb she's a senior data scientist, and she has nearly 10 years of experience in data science and NLP. She has a master's degree in computer science. And finally, Sun-Yang Fu is gonna go last. He holds a PhD from University of Minnesota. He completed his PhD only recently. He's also a data science analyst and a biomedical informatics researcher at Mayo. He has several years of experience in NLP, machine learning, predictive modeling, and EHR records. And his current research focuses in clinical research informatics, responsible AI, and EHR data quality.
Thanks, Ira, for the introduction. So in this workshop, I'm going to talk about general natural language processing, not the technical details, but the introduction, the covering multiple aspects, specifically in the clinical NLP. The clinical NLP specifically applied on the electronic health record. And here is the outline of this presentation. The first, I'm going to talk about what is electronic health record, followed by concept of natural language processing. Then what NLP can do, explaining various types of analytics. Then I talk about the NLP techniques commonly used in the clinical domain, followed by each of clinical NLP application in various types of analytics. An electronic health record, there is a structured data, such as the laboratory data, the represented by line code, the billing code like I-3910, and the SNOMED code, and the RX norm that consists of the medication information. These are structured data, so we can easily retrieve by using simple queries. But the good portion of each one consists of unstructured data. This is the free text, the clinical narrative. And often this is ungrammatical and the fragmented and use a lot of jargons and abbreviation. So for example, like a clinical note and weather report and the operation note. So for us, in order to extract some valuable information out of this clinical narrative, we need advanced technique, such as natural language processing. And NLP is basically a technique for computer to understand the human language and so be able to import a meaning. And you can think about the artificial intelligence as a whole. And the subset is machine learning. And within the machine learning, we have more advanced technique like a deep learning. But within the AI umbrella, we can also think about the expert-based system, such as rule-based system. And actually, this is the long history under the AI. And the rule-based system is quite often used in the clinical domain because of its flexibility and the customizability. And the NLP is a subset of AI that use machine learning, deep learning, and the rule-based techniques in order for the computer to understand the human language. So NLP can extract the information from unstructured data and convert it to the structured form so they can enable further information retrieval, information extraction, and knowledge discovery, and the clinical decision support. Then what do I mean converting from unstructured data to the structured data? Here is one example. If you look at the clinical narrative, such as clinical note, we can see the concepts without knee pain, no knee pain, denied knee pain, blah, blah, blah. There are many expressions. The same concept, but different patterns and vocabularies, but this all means same concepts. The symptom pain, the location knee, and it's negated, and the certainty is no. So all of these variants can be mapped to the specific, the QI, specific the identifier, and it's corresponding to the knee pain, and its certainty not present. So this is what I mean from unstructured to the structured data. Then what NLP can do and what value we can earn from it? We can answer this question by looking at the different type of analytics. And this is the analytic value escalator. It's been old pictures, but still good to understand different type of analytics. And here the x-axis is the difficulty, and the y-axis is the values. And from the bottom, there is descriptive analytics. And I can answer the question like what happens. This is more likely information extraction from the clinical note. And next level is diagnostic analytics. So this is like a disease ascertainment. The next one is predictive analytics. This is the prediction model and can answer the question what happened. The top one is prescriptive analytics. So they can answer the question, how can I make it happen? So in terms of the information perspective, this is from the hindsight, insight, and the foresight. And you can view this in different angles and each X separately. The X-axis is difficulty, and this is related to human environment. And as you go up, the human environment will be decreased. And at the top level, the prescriptive analytics, we may achieve full automation, but we still need a human for the actions. The y-axis is the values. And this is related to DIKW pyramid, like a data, information, knowledge, and wisdom. And as you go up, the value is increased. The one thing I like to point out is that I'm not saying one analytics is more important than another analytics. I just wanted to introduce different type of data use and what values we can earn from it. And actually in the clinical domain, the descriptive analytics, this is like information extraction out of the EHR, is quite important, it's quite widely used. And this can also enable the further advanced analytics. And next couple of slides, I'm going to talk about the clinical NLP techniques, the commonly used in the clinical domain. The first, dictionary lookup in the rule-based system, and machine learning, the deep learnings. So by the way, if you have any questions, you can just interrupt me and put the question in the chat box, then I can answer the question. The first, the dictionary lookup. And dictionary lookup is to search the concept of interest defined in the dictionary from the EHR. Then what is a dictionary? The dictionary can be national resources, such as the UMRS, Unified Medical Language System, that contains comprehensive the medical and the clinical terms. The summary cities consist of the signs and symptoms in the clinical domain, the RX norm that has the comprehensive medication information. So this is the existing national sources. But we cannot build custom dictionary depending on the project and the problems. And this dictionary contains predefined concepts by medical expert. So if we use the standard form like a UMRS, and we can enable interoperability between the computer system because we're using standardized terms. And there are the framework and the tools that can enable these dictionary lookups, like MetaMap, CTX, Meditag. Meditag is widely used in the Mayo Clinic, in the medicine. The second technique is a rule-based system. That's expert-based AI. And actually in the clinical domain, this rule-based system is quite common and widely used because it's flexibility, the customizability. And in the clinical domain, we have already known the criteria, the known guideline. So we wanted to implement this guideline and the criteria. Then rule-based system is quite suitable. And the one good advantage for this rule-based system is interpretable. So meaning that the outcome from this rule-based system, we know why the computer determines certain outcome. That's based on the rule, so that's clear. And also it's flexible, customizable. If we wanted to customize some logics and decision, we can customize that. But one of the big disadvantages for this rule-based system, it's quite labor intensive. So between the developer and the medical expert, they need back and forth to come up with the robust rules and come up with a good rule-based system. And there are certain framework we can utilize rule-based system, like a UEMA Luta and the Meditag IE. The next technique is machine learning. I believe most of you are familiar with this machine learning. And this is suitable for the problem with no explicit criteria. We don't know the rules. The pattern is hidden. So there are just the data. So we can feed this data into the machine learners so they can learn from. But the most traditional machine learning requires feature engineering. So meaning that we need to identify variables and feed it into the machine for machine learning development. And often, the traditional machine learning is not that interpretable, like a black box. So we don't know where a machine comes out certain decision. And there are some interpretable machine learners, like a decision trees, but most of traditional machine learning is not that interpretable. And we can use this machine learning system in different applications, especially in perspective of information driven. We can think about named entity recognition, so which is the identifying concepts out of the EHR text, and the adverse drug reaction and disease prediction and relation extractions. And there are certain popular techniques like a support vector machine, SVM, the conditional random field, CRF, and decision tree, NIBS, and the random forest. So I believe these techniques already been introduced by the previous machine learning workshop. The last one is a deep learning. And this is the subset of the machine learning field, but specifically this deep learning use artificial neural networks. One of the advantages of this deep learning, usually we don't know the feature engineering. We can just feed raw data into the deep learners so they can learn from that. And there are some popular techniques like a BERT, which is good for the contextual understanding. Now, the traditional machine learning is not that good or possible to understand the contextual meanings, but this BERT, this language model, we can do that. The recurrent neural network like RNN, which is good to incorporate the temporality of the data. And the CNN, which is convolutional neural network. So this is especially good for the medical image processing. And we can apply this deep learner for the same application in the machine learners. So for the following slide, I'm going to talk about the NLP applications for each of different type of analytics, starting from the descriptive analytics. And descriptive analytics is likely related to information extraction out of the clinical text. So I'm going to talk about the project like a medication information extraction using one of the NLP technique, dictionary lookup. And this task is to extract comprehensive medication information from clinical note and then normalize it to the standard form, which is the RX norm. Then what do you mean the comprehensive medication information? In the medication information, we have a medication name itself, but also it comes with different type of attributes, such as dosage, strength, frequency, route, duration, form. So for example, in the clinical text, we can see this sentence that containing medication information. And there are many potential mappings, mapping to the just ingredient and just the brand name and different combination of medication information. But we wanted to identify most comprehensive information and map it to the standard form, which is the RX-E, the RX norm. Then why do you need normalization? So here are some examples of medication description. And they are same concepts, but expressed by different vocabularies and the patterns. Like here, oral, by mouth, pure, but they are the same meanings by mouth. And here it used the abbreviation like a TAP. And some expression use the hyphen, this uppercase, lowercase, space. All this variation is actually different for the computer. So they can cause some medication error and hinder the efficient medication management. So that's why we need normalization. We can normalize this variant to the standard form under the RX norm, aspirin 80 milligram oral tablet, and map it to the unique identifier RX-E. Then how do you do that? We use the dictionary lookup. So this is the dictionary lookup techniques. The RX norm as a dictionary and use some pattern matching techniques like the regular expression and extract the medication information, names, attributes, then associate them together and convert it to the RX norm standard and map it to the RX-E. And for this task, we use a specific framework like UEMA. The UEMA is unstructured information management architectures. And this is the kind of software that enable effective and efficient unstructured data processing in the management. So most of the text processing at Mayo Clinic, our team used this UEMA framework. So this is the graphical view after we run the medication extraction system. So right panel here, we can see the medication name information. So we can extract these names and the corresponding attribute and map it to the standard form in the RX norm and the unique concept identifier in the RX norm. So this system produced a relatively higher performance compared to the other known medication extraction systems. The second NLP application is for this diagnostic analytics. So this is likely the disease ascertainment. So I'm going to talk about the automated chart review, the detection of the periprosthetic joint infection using rule-based techniques. The aim for this study is to identify the periprosthetic joint infection, examining different sources in the EHR, both structured and the unstructured data. And here I used the PJI definition from musculoskeletal infection societies. So there is a national definition for this PJI. So we know the basically rules, the definition of PJI from this MSIS. So we're digging into the different sources of EHR, the structured data, like microbiology in the lab, and also unstructured data, such as the pathology report, the consultation note, and the RPrep note, and this is the free text. So we need the NLP to identify them. And we leverage the expert knowledge from the orthopedic surgeons and the infectious disease specialists, get the textual biomarkers for this data element that is required to identify this PJI. Then we can apply this national criteria to define this PJI and come out with the final status with the reasonably good performance like a sensitivity, specificity, PPV, and MPV. And like I mentioned, we have a national definitions, this MSIS, the criteria for this PJI. So that's the rules. And also we leverage the expert knowledge from the orthopedic surgeons and the infectious disease. So that's why we use a rule-based system for the detection of this PJI from the clinical data. The next one is predictive analytics. Then I'm going to talk about the surgical site infection using the machine learning techniques. And this is the colorectal surgery. So after colorectal surgery, the patient may develop some type of surgical site infection, like a superficial, which closes the skin, and deep incisional surgical site infection. If it embedded to organ, that's organ-based surgical site infection. So there are 3 types of surgical site infection. And this project is to predict post-operative surgical site infection using Bayesian network. This is one of the machine learning techniques. And this technique is a graphical model-based machine learning technique. So after learning, so each variable, which is a node in the graph associated together with the probabilities. And we use a different type of the features, the patient characteristic before the surgery, and during the surgery and after surgery, and also some concepts and indicators within the clinical note. And these concepts result in the clinical free text. So we need NLP to extract this type of variable. And we use the different set of the variables, before surgery, during surgery, the risk factors, the keyword in the clinical note, the all combination of this one. And when it's all of them, the machine learner perform the best. And we compare the performance with the popular traditional technique, logistic regression in the clinical domain. And the machine learner performed higher than this logistic regressions. And this study used the surgical site definition from the NISCIP, the National Surgical Quality Improvement Program, that's annotated by human. But when we use the distribution learners, we are able to find clinically important surgical site infection that is missed by the human. captured in the NISKIP, but I mean, not captured by the human annotator, but captured by the machine learners. And actually, the surgical site infection captured by machine learner has the longer length of hospital stay, which is longer than the NISKIP. So we are able to find quite meaningful surgical site infection. So there is a good potential using this machine learning system in the clinical care. And the last one is prescriptive analytics. And you can answer the question, how can you make it happen? Then I'm going to introduce the application in the tailored care plan using deep learning techniques. And we did the preliminary study looking at the early signals of cognitive impairment, such as mild cognitive impairment and the dementia. And we looked at the activated living. And this activated living actually became much worse for the cognitively impaired patient, even much before a clinical diagnosis. So we looked at the instrumental area, which is related to the cognition, and the basic area. This is more related to physical functions. And this instrumental area actually worse than the basic area when you look at the patient overall temporal trend. So this happens even before the clinical diagnosis of the mild cognitive impairment and the dementia. And also we look at the clinical note, the clinical narratives, looking at the topics, and we are able to find some meaningful topics in the clinical note. And also with the prediction using the deep learning technique, using the recurrent neural network to predict mild cognitive impairment. And it performed reasonably good. Then how to use these techniques and the EHR, the tailored care plan, to early identify and predict MCI and the dementia. We can identify the patient distinct temporal trend by examining the multi-dimensional patient characteristics. So they can be able to find more granular, homogeneous patient subgroups. So from the EHR, we can expect patient temporal health condition and apply machine learner and the deep learner and identify subcluster of the patient and associate them with the subtype of the cognitive impairment. So basically, we can identify the homogeneous patient subcharacteristics. So that subcluster, we can apply more tailored care plan. So they can enable tailored care plan using these advanced techniques. So until now, I introduced some NLP applications for each of the different analytics. And we used different NLP techniques for the descriptive analytics. We used the dictionary, and diagnostic analytics, we used the rule-based system. And predictive analytics, we used the machine learning. And the prescriptive analytics, we used the deep learning. So there are many techniques for the NLPs. Then what is the right approaches? And this is actually not about the selecting whatever the most advanced and advanced technology, but about understanding the strength and the weaknesses of each of these techniques and the nature of your project and the tasks. If you know the rules, like periprosthetic joint infection dissection, there are national criteria, national definition. We know the rules, then we can apply rule-based system. But if we don't know the rules, we just have input and output data, like a prediction of surgical site infection. We just know some variables, but we don't know the clear the rules to predict the surgical site infection. Then we can apply machine learning. Then machine learns from the data, come up with their own decision logics. And we can think different perspective, like a data perspective. And we can think about the size of data and the variance of the data. If it's complicated, well, not complicated. And if we have a large number of data and the variance is quite complicated, we can apply deep learning and the machine learning techniques. If the data is relatively small and relatively less variance, relatively simple in terms of the patterns, then we can apply rules and the dictionary lookup. And we can view this in user perspective, considering the customizability of the logics and the interpretability of the outcomes. And if we need the high customizability and interpretability, we can apply dictionary lookup and the rule-based one. But if it's not, we just care about the performance, we can apply the machine learnings and the deep learnings. And of course, we can use the hybrid techniques depending on the taskers. So actually, this is the end of my slide. So I have talked about different type of clinical NLP techniques and the NLP applications for each of different analytics, and talk about some insight how to choose the right approaches. So hopefully, so this talk will be useful how to use the NLP in your current and the future projects. So that ends my talk. So, and thank you for your attention.
Hello, everyone. I am Elham Saqib from Department of AI and Informatics. And in the following slide, I'm going to talk about an examples of NLP project in orthopedics. I'm going to walk through the steps and tools that we typically apply for a rule-based NLP project by providing you an examples of one of our projects. The example project that I selected is automated detection of the type of scoliosis surgery from operative notes using NLP. Let's talk about a little bit about scoliosis surgery. Scoliosis is abnormal curvature of the spine and managed surgically in severe cases. There are three common types of scoliosis surgery: growing rod, fusion, and non-fusion. The type of scoliosis surgery is not available in structured data, but it resides within the free text of operative notes. Our goal in this project was to implement an NLP algorithm to detect the type of scoliosis surgery from operative notes. The first step would be determine the cohort. To determine the cohort, we might use available registry data like what we have for total knee or for total hip arthroplasty, and we might use a database or Excel files, data files that the Department of Surgery or other research collaborators have, or we might use MDE, which is a Mayo Data Explorer, which is a web-based tools available at Mayo, and we can search by CPT codes, for example, or ICD-9 codes to find our cohorts. After determining the cohort, we need to obtain the clinical notes that we want to use in our NLP project. For example, operative notes. We have in our department, AI and Informatics, we have a tool Synchrony that enables us to download the notes that we need based on our cohort and by having our IRB. This is a Java program, and I am aware that there are other tools available at Mayo that makes us able to download the clinical notes. The next step would be preparing an annotation guideline, which is basically says how to label the data. We need to work with experts in clinical domain for preparing an annotation guideline. Documenting an annotation guideline is very important. Help us to bring both clinician and informatician on the same page within a standard framework. It helps informaticians to learn the rules from clinical domain experts. It makes annotating process consistent between multiple annotators when we have different annotators for our project. When we have annotation guideline ready, we need to prepare a gold standard. The gold standard is actually labeling the data based on annotation guideline by domain experts. Because, for example, me as an informatician cannot label and detect the type of surgery, but we should ask surgeons or medical expertise to label the data. When we have the gold standard ready, we usually pick one side of data for training purpose, and we put aside one part of data for testing our NLP algorithm. Here you can see some of the key terms and rules we found and applied in our scoliosis project. For example, we learned that if we found fusion or bone graft in the operative notes, is related to fusion type of the surgery. Relatively, we can see other terminology that we learned for each of the other categories. During annotating process and implementing algorithm, we might update these rules. We might add exclusion, inclusion criteria. It is time to implement an NLP algorithm. There are different tools available. One of them is Methodologies, which is developed at Mayo Clinic, but it is an open source program. So people can use it out of Mayo. We might use NLP as a service, a web-based application, another kind of shape of Methodologies, but is a web-based process. We might use other programming languages like Python or other languages. And we work based on annotation guideline. Then we need to evaluate and optimize an NLP algorithm based on trained set and based on the discrepancy between gold standard and NLP result. This is an iterative process. We should go back and forth as clinician, learn something and check the performance and optimize an algorithm. Sometimes we should add more inclusion and exclusion criteria or terms, or sometimes we need to review the notes in the clinical domain. We in informatics side usually use ATE, Advanced Text Explorer, a web-based application at Mayo, which enables us to easily review the notes. This link is available for all Mayo employees after getting and requesting for access. And then you can search by terms, clinical numbers, or many other criteria and easily see the notes by their category like pathology, radiology. It is very helpful for us to reviewing the discrepancies. When we are happy with our evaluation, it is time to finally evaluate our NLP algorithm, this time based on the test that was not seen by NLP so far. This is a final evaluation. We need to, usually we pick a metric that is more fit to our project. Some projects are more focused on increasing precision, some projects focusing on increasing sensitivity or recall, depends on the nature of the project. We usually use F1 score as our metric for rule-based project in NLP to show and project the performance of our program. And the numbers over 0.9 usually is a good numbers that shows the performance is reasonable and acceptable. And you can see our NLP algorithm performance for our example project for each of this category. And F1 score actually is a balance, a metric that shows the balance between both recall or sensitivity and precision. So if the both is a good numbers, we can achieve F1 score high over 0.9. These are some of our other orthopedic projects using NLP methods, just to name a few: automated identification of total knee implants in EHR, use of NLP algorithm to identify common data elements in operative notes for total hip and total knee arthroplasty, automated detection of pre-prosthetic joint infections and data elements using NLP. Thank you. Now my colleague, Dr. Sun-Young Fu from Department of AI and I will continue the presentation. Thank you.
Thank you, Elham, for introducing the process of conducting NLP in the context of AJRR environment. I'm going to talk about the current potential challenges and the future opportunities for NLP-assisted clinical research. So this is the high-level overview of the process that Elham just talked about to develop, evaluate NLP algorithms within a AJRR environment. As you can see, the steps are quite iterative and involving multiple domain experts across multiple interdisciplinary collaborations, dealing with data infrastructure as well as institution level of potential variations. And this issue could potentially exacerbate it when we're collaborating and try to deploy a mature NLP solution to different institutions. That emphasizes the importance of multi-site research. And so multi-site research plays a significant role for larger scale discoveries, external validations, minority recruitment, etc. Even under the present pandemic, we see there is a crucial demand to integrate large volume data, diverse data to link across different institutions. And under this project led by Dr. Marty Kremers and Dr. Song, we're aiming to leverage NLP to establish a nationwide arthroplasty registry. So this is starting by the process of leveraging Mayo Clinic Joint Registry to develop a NLP tools. And then after we do external validation across 3 sites, University of Iowa, Michigan, and North Carolina, the purpose is to perform external validation and optimize the system to be generalizable enough, and then apply to all other sites with the aim to establish a national arthroplasty registry. So now I'm going to share some of the pragmatic challenges and gaps regarding the execution and implementation within the multi-site environment. So in this presented figure, it summarized a high-level view of the external validation and refinement process that involves both development and deployment sites, including both research process and administrative process. So now I'm going to share some of the challenges that we encountered from 4 distinct perspectives. So starting from the people perspective, we learned that different sub-award sites have different local expertise, and successfully complete the process requires a minimum 3 types of expertise. This including the domain knowledge of total joint arthroplasty, the local ETL or extract, transform and load or data infrastructure knowledge, and as well as basic NLP development and evaluation knowledge. This is responding to react when there are potential technical bugs and try to fix the local issues for optimization. But we learned that none of the sites that we are collaborating have all the expertise available when the project started, and it will take some efforts and communication to help establish the expertise. Even we try to reach out to help the institution reach out to other departments for job posting. The second aspect would be the institutional specific security policy and processes. We observe there has been a significant impact to the time and effort related to the exchange of information resources during multi-site collaboration. So this including to obtain security clearance first start sharing NLP systems to a local secure environment. So this process can change actually from days to months, depending on the local institutional policy. It also has a strong impact to when we want to sharing the NLP results for error analysis and refinements. So that needs to be aware through a better collaboration. The third aspect is regarding the maturity of institutional local ETL and data infrastructure. At beginning of the project, we assumed that data retrieval would not be a barrier until we learned that there is potential sites struggling with automatic data retrieval. But we end up identifying ad hoc alternative solution to be able to still obtain the data in a relatively scalable fashion. And then from the clinical data perspective, especially for unstructured nodes, we learned that there is also potential high variation regarding the syntactic and semantic structure and meaning of clinical documents. For example, institution we find clinical notes can be represented in a non-searchable scanned PDF format. Eventually, we're able to identify a freely available OCR, object recognition solution, which can scan the PDF into a raw TXT format for NLP to run. So just to put this heterogeneity aspect to the previous process, you can see it's the entire process is can be impacted by all four different aspects. So that the big lesson we learned that the NLP deployment not only directly send over the NLP system to a site, but we need to work closely with the local institution, with their local team to have strong communication, as well as iterative discussion and consensus development to make sure the system is not only runnable, but also be able to obtain similar results and then try to refine and optimize the NLP performance to an optimal fashion. So now we can put these heterogeneous factors from the process of information generation and information use. So we'll be able to now view that NLP is rather than a single black box or transparent tools, we need to understand its interaction within each environment. So that kind of summarize the potential gaps that we need to pay attention when we try to develop and deploy NLP, especially in the multi-site clinical environment. So these challenges including standardization, interoperability, knowledge management, people-driven interpretation, decision biases, different methods of choices, quality of implementation, information availability and accessibility. So this is a case study that we conducted at Mayo, tried to visualize the data ETL process. Basically, before we obtain the data, what's the process the data actually being tracked? So if we pay attention to the bottom figure, for Mayo unstructured data, it started with the HL7 messages. And during the ETL process, it converts from the RTF format to plain text. We discover potential information loss during the metadata of the information. Eventually convert to the raw free text within the environment. There is also a syntactic and section information loss. So these are potential information loss discovered during the ETL process. From the data and information resources sharing perspective, we compared Mayo Clinic versus Olmsted County by look at how easy we're able to share information resources across intra-institutional and intra-institutional environment, and we learned that there is a remaining challenge for us to sharing artifacts and information resources data across institution, and this sharing ability needs to be aware prior to the planning, during the project for multi-site project planning. Then we'll, after Mayo implement the EHR system migration from previously Centricity to current EPIC system, if we look at the syntactic semantic structure of clinical documents, we learned that EPIC actually have increasing number of documents, number of tokens, and number of sections after switching to Centricity. But if we look at the total number of tokens per sections and numbers tokens per document and tokens per patient, Centricity has actually significantly higher than EPIC, indicating original Centricity nodes has higher information density compared with EPIC, although the total volume increased, but the density gets sparse. So this also has implication to the NLP system processing and development. We also compared the language standardization between EPIC and Centricity. This is indicated by the textual similarity score, where 4 equals standardized and 0 equals non-standardized. So in general, Centricity language in the context of post-surgical complication, if we look at abscess, anemia, period and drain, wound infection, has a medium higher number of similarity score, indicating that the reports language is more standardized than EPIC. Except for secondary diagnosis, where EPIC language is more standardized. And later we learned there is potential auto documentation and templates plays a significant role in this section. And NLP also requires ability to process and detect sections within the clinical nodes. So this is a comparison of the section distribution between Centricity and EPIC. And through this comparison, we learn the majority of most common sections are mostly aligned. But based on the CDHL7 standard, there are still 10 for EPIC and 24 for Centricity that are not able to map within a lower frequency range. So to address these aforementioned issues, it is important for us to adopt quality frameworks. So here we present 2 frameworks. One is FAIR data principle that emphasize the data when trained on a machine learning models that needs to be findable, accessible, interoperable, and reusable. In the context of clinical environment, we also emphasize the right implementation principle that emphasizes the process transparency and results correctness, explainable and reproducible. So looping back to the previous development process, we can now start to develop standardized process and best practices for EHR-based clinical research assisted by NLP. So this figure is a enriched version compared with the previous figure that emphasized what Elhan mentioned, the importance of have a team science collaboration, detailed definition of the inclusion and exclusion eligibility criteria, and perform standardized data clinical document retrieval process. And then during corpus annotation, which is a process of established gold standard data set, it is important to ensure that the quality of the corpus, meaning the agreements between multiple annotators, needs to be valid and reliable in order to moving forward to the development effort. And as Dr. Song mentioned, when we're picking the right choices of model, it is important to consider the context not solely based on the performance, but the practicality, customizability, and usability as well. So lastly, when the model development is finished, it is also important to properly document and report the findings, especially now NLP has been heavily integrated within clinical research. The findings can affect the outcome of clinical research. So therefore, it is important to comply with current existing reporting standard. However, there is no specific criteria for EHR-based methods. So efforts are needed to document and standardize the validation and development methods during the reporting for the reporting guideline. So with that, I will hand over to Gilad.
Thank you, Sunwon, Elham, Sunyang. This presentation concludes the series of four workshops that we have done over the last 2-3 months. Thank you all for attending, and thank you to the presenters.